Hello everyone, Doug Simonian over at New York Metro Weather with your latest video discussion. The active pattern for early March will continue as we are tracking yet another storm system. This time it looks to impact the area on Wednesday of next week, so it's actually not too far away now. But this storm could be more of a snowy solution for the immediate New York City and adjacent suburbs area than the previous storm was, which was more so of a snowy situation for areas much further inland. And in this video we're going to be discussing three models: the European, the GFS, and the NAM. The European model is a little bit further east with the storm, the GFS is further west, and the NAM is somewhere in between. And we're going to discuss why the models are doing what they're doing, which solution we think has the most credence, and what adjustments may have to be made to some of the other models. So let's get started by taking a look at the European model at 500 millibars to the middle of the atmosphere. We see valid on tomorrow morning, Monday morning. We see the main impetus in the atmosphere for the storm to develop is this elongated shortwave trough that is digging well to the south into the central and even parts of the southern plains, which is going to give a nice snowstorm to the northern plains and parts of Minnesota into Wisconsin. So you'd think a lot of times with the elongated 500 millibar low in this location, that's not really ideal for a snowstorm, and it isn't. However, the way it evolves as a response to the blocking pattern makes it a much more intriguing scenario for snow along the East Coast. And we can scroll through the evolution and see why. 6 hours later, 12 hours later, we get a dual blocking area set up as the elongated 500 millibar low is forced to keep tracking south and southeast. So eventually you get what we kind of call an elongated bowling ball, so to speak, that slowly moves eastward. And with the blocking pattern, we force this big upper level low from the previous nor'easter to still kind of stall and meander along the northwest Atlantic for a pretty long time. And what that does is it dampens the ridging out ahead of the storm. So with less ridging out ahead of the storm than you usually would get with the circulation this far west, that opens the door for a storm to track underneath the area, and thus a snowy scenario. So it's really important to emphasize the blocking pattern and why we've been discussing the blocking for so long and how it really could impact the storms as we headed into early March. And of course, in between these blocks is we have this lobe of energy that is detached from the polar vortex. We see that in the initial parts of the run, the blocking south of Greenland forces that lobe to split, with the eastern part of that lobe phasing into the upper level low from our nor'easter, which actually may lead to some light snow along the New England coast, believe it or not. But that phases with the upper level low with our nor'easter, enhancing the area of resistance that leads to the ridging to get suppressed. And then the split off piece remains in southern Canada, ready to tap into our storm because the blocking is pushing it south. Without the phase with this energy, this elongated bowling ball would result in an occluded storm system with no real room for development, and thus a cold front, which is what the models were showing a few days ago. But now that we're getting this phasing with this lobe of energy, we're able to reinvigorate the storm and tilt it again to help it redevelop. And this tilting to the trough leads to a very intriguing dynamic solution across a lot of the area. So this lobe phases in and we get a much more favorably tilted trough into the area for a big storm to develop. As we see, this becomes a large trough, negatively tilted along much of the East Coast, and we see the blocking remains intact to the north of the storm, so there's only so much room for the storm to come west. And then the main shortwave energy actually ends up trekking off the coast, swinging like a pendulum around the top of the swing, so to speak, which was acted on by that polar vortex lobe phasing in. And it actually turns out that the European model run verbatim, that swing, so to speak, the pendulum was a little bit further east than what is ideal for a major snowstorm across the area. And it's because of the fact that it lingers, this blocking, for a pretty long time, and it suppresses the baroclinic zone almost too much. And then also the lobe of vorticity doesn't phase in as aggressively as some of the other models, and we'll get to that. We'll elaborate more on that shortly. Here's the European model at the surface. We see that, yeah, that little phasing with the splitting vortex leads to some light snow across the eastern New England coast. And then as you scroll through time, we see the snowstorm in Minnesota, but then the storm occludes initially. But because of the phase occurring, look at these very low thicknesses in the U.S.-Canadian border as a response to that lobe. That phasing increases the dynamics and increases the temperature gradient again along the east. See, the baroclinic zone, the temperature gradient, is initially not that strong in the east, but we notice that the gradient starts to tighten along the Tennessee Valley and the southeast coast. However, even not too long prior to the storm's development, on the European model, the baroclinic zone, it's still kind of weak and not that tight and not that amplified. So the storm has a lot to quote-unquote make up for and tighten the baroclinic zone to get the storm to cut further northwest. And we see that with the baroclinic zone, which really is just a fancy term for the main temperature gradient along the storm's axis, is still kind of weak on Wednesday morning. And then it does get stronger Wednesday afternoon, but at that point it's a little too late to really get that storm to curl in for the northwest. So you get a good snowstorm for Long Island and southern New England. But even there, the potential, especially on Long Island compared to the ceiling, still isn't what it could be. And then for areas further west, you get only in lighter precipitation. And thus, at this time of year, with light precipitation, the sun angle would actually mean it wouldn't accumulate too well. Of course, with heavier precipitation, the sun angle doesn't matter, and you'd get snow. But they're just showing you the European model escapes a little bit to the east because there's almost too much blocking, and the baroclinic zone thus is initially weakened and suppressed. On the GFS model, we notice a little bit of a different evolution. First, we can compare the blocking. The European model has a stronger block in southeast Canada, a more organized closed contour, and the upper level low is bending a little bit further westward back towards the coast, which suppresses the baroclinic zone on Tuesday morning. The most recent GFS model, it's similar, but the upper level low, it's not as strongly backed in towards the coast, and the blocking is just a little bit weaker. And the lobe that phases in also does so more aggressively and more efficiently as a result. So we can even see that the height lines, the European has more of a tighter gradient with those height lines bending westward towards the coast. The GFS does not really have that same exact, it's subtle, but it's not the same exact degree of resistance. We even see the ridging sort of link up to with the blocking at 48 hours, which is 18Z, 1 p.m. Tuesday. The European model at that same time, it's not as directly linked. There's still leftover lobes of vorticity and confluence in between the ridging and the block. So the block is still its own circulation. See, the ridging is closed off. So the blocking is still separate from the East Coast ridging, whereas on the GFS, the blocking is not as separate from that East Coast ridging. So there's more room for amplification ahead of the shortwave. And we see that on the GFS, the polar vortex lobe phases in very aggressively. So we see that at 12Z Wednesday, it's already very much embedded into the circulation. And on the European model, at that same time, it's embedded, but it's positioned and oriented differently. Then on the GFS, it's more so aligned with the trough in a north to south fashion, so it's more amplified. On the European model, it's more so aligned in a northwest to southeast fashion. So that is a big difference as far as the verbatim surface result. So the GFS model, its pendulum swing, so to speak, is further northwest, as a result, and the blocking also is weaker. It more so connects with the ridging over the Atlantic, whereas on the European model, the block is still more so its own feature. There is some connection, but the ridging doesn't immediately just scoot out to sea. It remains its own entity and its own feature, which is something we think is probably more accurate given the degree of the blocking that will inherently occur in this type of pattern. So I do think the GFS is probably a little bit too far to the northwest, but I can't say that with certainty because it's also possible the European model is overdoing the initial upper level low influence that suppresses the height field along the east coast. So either way, you still get a very dynamic solution on the GFS, and actually for inland areas, it's a much more significant snowstorm. So we can look at the surface now on the GFS, and we see that the low pressure is much more tucked in towards the coast. You can't take these precipitation types verbatim, but I mean, with the low that close to the coast, southern Jersey would be rain as onshore flow would, a strong onshore flow, look at the pressure gradient, would hit the New Jersey coast and definitely mean a rain event for them if the GFS were right. Further north, it probably is a mix of rain and snow along the coast, with precipitation being lighter, but then inland, look at this really strong heavy band of snow that forms all throughout New Jersey, into New York City and into the New York City suburbs, especially the immediate northwest suburbs. And Long Island, this precipitation type map remains rain, but just like with the last storm, the GFS tends to be too warm at the surface in the midst of heavy precipitation. We could even look at a sounding on the GFS model in western Long Island. It's a really cold profile. There actually is some dry air aloft, and we'll get to why that is in a bit, which is actually why the GFS is less snowy on Long Island with the band, not because it's too warm. The profile is certainly cold enough for snow, but the surface is, for some reason, not saturated on the GFS despite the heavy precipitation, and it's also what we call too mixed. The slope is way too strong in the midst of heavy precipitation, and the winds actually are very much northerly and northeasterly at the surface, so it should be colder. However, there is some drier air aloft because the mid-level centers are a little too far west for a major snow event for Long Island on the GFS, but just inland really gets crushed on the GFS with easily 6 inches or more, maybe 10 inches or more in some spots. And then the low scoots off to the east, and it does change over to snow on Long Island. Granted, I didn't think it'd really be that much rain. I think the GFS is acting too warm, but with the storm as close to the coast as it is, the mid-level centers aren't as favorable for the heavy banding along the coast. They're more favorable, whoops, that's the wrong map. They're more favorable further inland. We see this is the 700 millibar low is closed off right on the coast at that hour, at Wednesday evening. You do get the circulation, see the counterclockwise flow right along South Jersey. So really, the 700 millibar low is a tight circulation right on the New Jersey coast. It's not this broad low across all of New Jersey and Long Island. So areas just to the north and to the northwest of that closed 700 millibar low are going to get into that heavy snow banding. So that's central and North Jersey, probably into New York City and the southern suburbs of New York City on the GFS. But again, I think this is probably a little bit too far northwest, but I can't say that with certainty. And the 700 millibar low scoots off to the east and then really crushes New England also with a good snow event. Another interesting facet of the storm is that it's a very tight circulation. So generally you think, oh, the storm's so close to the coast, it has to be an all-rain event with that trap. That's not the case with the circulation that is so tightly wound. This is Wednesday afternoon. We see, even with the low pressure pretty much hugging the southern New Jersey coast, the winds are actually north of due east. They're northeast. It's not like you're ushering in all the southerly, southeasterly flow. The circulation is tight, so you're able to get this counterclockwise flow really rushing in towards the center, and that really holds true 6 hours later on Wednesday evening. The low is hugging the southeast New Jersey coast, but it's such a tight circulation that, look, look at the wind barbs. They're due northerly, even along the immediate coast, and northwesterly in parts of the New Jersey coast as well. So this is able to very efficiently yield cold air advection. So even with a storm this close to the coast, any initial rain would have to change over to snow. So the verbatim track isn't always that important. You have to take into account how tight the circulation is. You know, if the circulation were more broad, this would be a all rain event for pretty much the entire area. But with the circulation so tight, the banding has to be more compressed as well, and the winds are more compressed northerly towards the center of the storm, and thus it's colder. So that's why also, not only would this rule apply to the surface, but generally, you want to be a certain distance away from the 700 millibar low to get into the heaviest banding. But but notice how compact the counterclockwise flow is. With the circulation more compact, the banding isn't going to be as far away from that 700 millibar circulation as it usually is. So that's also why I think the I-95 corridor could really do very well in this, very well in the snowfall department in the storm, should the ingredients work out to their potential. Now here's the NAM model, which is if you're a snow lover, it's the in-between scenario that you would really want along the coast. Though of course inland regions would gladly take the GFS if you're a snow lover. It phases in the lobe, the polar vortex lobe, but still not quite as efficiently as the GFS. The circulations remain somewhat separate. The blocking is still a closed feature northeast of Maine. I can't get into it's hard to get in a more zoomed out map on the NAM because the more zoomed out North America maps are outside the NAM's domain, so we're looking at the US. We see that the lobe phases, but it doesn't aggressively dive in southeast towards the coast like on the GFS. I mean, not that the GFS really dives southeast either, but the GFS more so has the pulling effect to the circulation, almost like a magnetic effect, for lack of better terminology, towards the lobe. The NAM keeps it a little bit more separate, and thus you get a very well-defined 500 millibar low southeast of the area, which is really classic for heavy snowfall banding across the area. So it's really the in between the NAM and the Euro. Sorry, in between the GFS and the Euro, I should say. So at the surface on the on the NAM, we see there's a tightly wound circulation, definitely further southeast of the GFS. But the NAM is a mesoscale model, so it tends to better pick up on how quickly the surface temperatures are going to cool in response to lift and heavy precipitation. So even with the low pressure tucked in, maybe not quite as close to the coast as the GFS, but pretty darn close to the coast, you see there's heavy banding of snow across all of the coastal New Jersey even, and Long Island as well, and the NAM just crushes the entire area with a cold conveyor belt band. Yes, so the NAM model, while it's initially very close to the coast, it's able to crush the area with the cold conveyor belt band because it's a tightly wound circulation, and the low pressure can only come so far north as a response to the blocking pattern, and ends up kind of stalling to the east and southeast, and the banding just sits over the area. So if the NAM were right, this would be a mini blizzard. And so with the potential ingredients and dynamics to the storm and the tightly wound circulation, the solution can't be ignored. And again, we can look at the tightness of the circulation with the surface winds. See, we have this secondary dual low pressure center very close to the southern New Jersey coast, but look how tightly wound the circulation is, and thus the northerly winds rush towards the center of the storm. So along the New Jersey coast and Long Island even, the winds are almost due north. So you're able to get a much colder solution. And when you combine that with intense lift and heavy precipitation, you're able to change any initial light rain over to heavy snow that would accumulate, especially with the fact that a lot of the banding on the NAM occurs from 4 p.m. and afterward on Wednesday, so you're able to time the heavier precipitation with when the sun sets, and thus when the surfaces would be less warm due to the sun angle not being a factor. And then the storm just kind of slowly turns off the coast. Look at these very strong northwesterly winds off the coast. So on Long Island, you're getting some 25 to 30 knot sustained winds. So you're getting some blizzard conditions for sure if the NAM model were to be right. And now we can take a look at the 700 millibar low, compare that to how it looked on the GFS. See, we see that, notice how on the GFS before we had that counterclockwise circulation. It just didn't show up in the in the height contours. But on the NAM, it's a little bit more compact. So you're actually getting a closed height contour to represent that tight counterclockwise flow just off the southeast New Jersey coast. And with the compact circulation, the 700 millibar low being in this location is ideal for heavy snow banding across all of New Jersey and Long Island and New York City, and also even the adjacent suburbs as well. They all do well in the snow department on the NAM model. And the 700 millibar low continues to intensify and essentially stall off, well, not really stall, but just meander very slowly off the coast. So you're able to continually promote heavy banding across the area. Also, with the northerly winds at 700 millibars somewhat colliding with or converging with the southeasterly 700 millibar winds, you're able to get a tightening of the temperature gradient. You know, the northerly winds are, with colder air, are being brought into what's theoretically advecting in warmer air. So you're able to get in more frontogenesis and thus additional mechanisms for heavy banding to affect the area. So that's why the NAM is a really impressive snowstorm and pretty much a mini blizzard across a lot of the area, with 10 inches or more of snow across the whole area. But sometimes, you know, the NAM can be a little bit aggressive with the snow totals, especially in the longer range. And again, as we said before, the European model is not as impressive. It's a little bit further east with the storm, and I still do think that the potential east tick is something that snow lovers should be a little bit more worried about than the storm continuing to go west, because of the blocking and because of the upper level low lingering and suppressing the height field. And also, sometimes the GFS can be a little bit too aggressive with phasing in northern stream energy. It can go dig northern stream energy a little bit too far south. But again, sometimes, you know, the European model does go overboard with upper level lows. So it's also possible the European model is suppressing the baroclinic zone too much, and maybe the GFS is right, or maybe the in-between NAM model is right. So it's really hard to go either way, but I do tend to lean more towards the maybe a NAM Euro blend, or you know, maybe even a GFS NAM blend, something like that, as far as the way the storm goes. And then at that point, we'll have to monitor the intensity of the precipitation and when exactly it moves into the area, because, you know, lighter precipitation, let's say if the dynamics were to escape to the east, could result in not much snow accumulation this time of year. Also, if the GFS were to be more right, and the heavier precipitation as a result of the 700 millibar low being further northwest also ends up further inland, then areas further east, while they could cool down thanks to the northerly winds, they won't get the lift for precipitation, and thus snow also wouldn't accumulate as much along the coast. So there's certainly a lot of fine-tuning and nuances to track with the storm, but overall the potential is certainly there for a quick-hitting, intense snow event on Wednesday through Wednesday night. So we'll be sure to keep you posted. We hope this video was informative, and we'll talk to you guys soon. Take care.